Hello guys, welcome to my YouTube channel eStudy. Today we will learn minimum spanning tree, abbreviated as MST. So let's begin with its definition. A minimum spanning tree is a subgraph of an undirected weighted graph. So to understand any topic, we need to understand some keywords. Here, the main keywords are subgraph and undirected weighted graph. So we need to understand the subgraph and undirected weighted graph first to understand the minimum spanning tree. Let's look at this example. Here in figure 1, it is a tree or graph. It's definitely a graph because in tree it cannot be any cycle. So this graph includes 4 vertices, namely A, B, C and D, and 4 edges, A to B, A to C, B to D and C to D. So all the edges are undirected. Because this edge A to B, we cannot say that it starts from A and end to vertex B. Alternatively, it starts from B and end to vertex A. However, if we put an arrow here, now we can say that this edge starts at A and end to B. As this graph does not contain any arrow in edges, so we can say it is a undirected graph. Now here look at the number 9, 5, 5 and 5, numerical values assigned to each edges. So this values is called weight. This weight can be any measurable values, like it can be the distance between these two vertices A and B, it can be the time need to travel between this distance, or it can be any measurable cost. So now this graph is called an undirected weighted graph because the graph is undirected and the weight is assigned to every edge. So we understand the undirected weighted graph. Now we have to understand the subgraph to understand the minimum spanning tree. So look at the figure 2. Here is a simple graph. So a subgraph is a portion of an graph. So here the portion A to B and C, which is in the main graph A to B, and here is C. So that's why we can say the figure 2 is the subgraph of the main graph figure 1. Similarly, the figure 3 A to B and D is the subgraph of the main graph A to B and B to D. Similarly, we can say that the figure 4 contains 4 vertices A, C, D, V is the subgraph of the main graph in figure 1. So can we tell that a subgraph of an undirected weighted graph is minimum spanning tree? No, not yet. This tree must meet some conditions. Number 1, it is a tree, it should be acyclic. So here is a subgraph as well as it is tree because there is no cycle here. However, if we put a connection here from C to B, now it's only graph, not tree. So for minimum spanning tree, it should be a tree. Here this is also a tree, and in figure 4 this is also a tree. Now in another condition, it covers all the vertices. So let's see in figure 2. it does not cover the vertex D. Here in figure 3, it does not cover the vertex C. However, in figure 4, it covers all the vertices of the main graph A, B, C, D. So this graph only is called the spanning tree. Now the next condition is the total cost is minimum among all possible spanning trees. So can we tell this is the only spanning tree of this graph? No, it can be many more. For example, here the figure 1 contains a graph, the undirected weighted graph. In figure 2, it is a subgraph of this main graph, as well as it covers all the vertices of the main graph. Similarly, figure 3, it is a subgraph of the main graph. It is tree and it covers all the vertices of the main graph. Similarly, in figure 4, it is a tree, it is a subgraph, as well as it covers all the vertices. So all these three we can say are spanning tree. However, the minimum cost among all possible spanning tree will be called the minimum spanning tree. Now we should calculate the cost of this spanning tree. So here is 9 to 11, 4, 15 and 4, total 19. For this spanning tree, 2, 4, 6, 4, 10 and 5, 15. For this spanning tree, 2, 4, 6, 4, 10 and 5, 15. So the minimum spanning tree will be this one and this one. So a student can draw this one and another student can find or draw this one. Both are the correct result. That's why here is a property, the minimum spanning tree not necessarily unique. However, their cost must be same. So here is 15 as well as for this example is 15. So if we look at the figure, here the connection from D to B with edge value 4. But in this graph, it connects from vertex D to E with the same edge value 4. So if we take any one from these two edge, it does not change the total cost. So the total cost will be same. However, the figure or the structure will be different. That's why the minimum spanning tree is not necessarily unique. Now the question is how we can calculate the minimum tree spanning cost. There are two algorithms, namely Kruskal algorithm and Prim's algorithm for finding the minimum spanning tree from a graph. So we'll talk about these two algorithms in next videos. So now you should pause this video and try yourself. Are figures 2, 3 and 4 spanning tree of this main graph figure 1? Please leave your answer in the comment box in this video. I will reply right away. I think you understand the topic minimum spanning tree. Still, if you have any question, please leave your question in the comment box. I will try my best to answer all of your concerns. Thank you for watching this video.